going to demonstrate a quick and easy way to mark the medial and lateral malleolus for digital scanning for the provision of 3D printed Richie braces. So we have our model here, Ellie. So we're going to ask Ellie to lie up on the plinth on your tummy. So she's going to be in a prone position. And we're going to scan the left foot because when we open our Fusion scanner, the option to scan left foot is the first option. So we're going to raise the contralateral hip and knees in the frontal plane. And if we do a slight dorsiflexion on the lateral side of the foot, finger on the fourth and met heads parallel to the webbing, we load the lateral column, we lock the mid-tarsal, and this foot is now at 90 degrees relative to the ankle, as well as having the lateral column mid-tarsal locked. Now I'm going to ask Ellie just to hold that for a moment, and that's the ideal position that we want to scan the foot in. When you ask the patient to hold the tibialis anterior, we'll fire here slightly so you get a slight increase in the varus angle. Our software will be able to correct that to all met heads on the same plane. Just relax for a moment, Ellie. I have here standard semi-compressed felt 5mm, and I'm going to cut two small pieces about the size of your little fingernail, and I'm going to place it on the medial and lateral malleolus at the most inferior prominent point. So in true Blue Peter fashion, I already have two of these made. So you can see they're two little circles of semi-compressed felt, beautifully beveled, which tells you I've spent many's a time in a routine general practice clinic many years ago. So on the medial side, just on the prominent medial malleolus, and conversely we will do exactly the same on the lateral malleolus. And this then is picked up in the 3D scanner, which allows us to orientate the hinges for the ankle joint axis specific to this patient. I now open up Fusion app, select scanner option. I've put in the patient's details, and now I'm going to ask the person to just simply hold the foot in this position. And now I can start the scanning process. And I'm just filling in all of the data, and I'm making sure I've got the medial and lateral malleolus. And at this point then, you can see the 3D scan, which has picked up the prominent point, which is the semi-compressed felt. Foot is at 90 degrees relative to the ankle. You've got a great MLA shape. Mid-tarsal is locked. This is ready to go straight into the software design, and from there into the 3D printing of the sustainable plant-based material. Now, another little way of doing this is if I ask you, Ellie, to stand up, and I'm going to lower the plinth initially, and I'm going to ask you to put your left knee up on the plinth. Now, if this is an older patient, you may have to do this from the side of the plinth and have the top aspect of the plinth raised so the person can use it as a balance. So in this position, you've actually caused this flexion in the knee. This relaxes gastrocnemius, so you don't have any effect from an ankle equinus. And now you've got this very flexible floppy foot. And again, you want to load that lateral column. So we move to this position, ask the patient to hold it. And again, you're ready to scan. This is a very successful way of scanning, and we find it probably more effective than lying prone on the plinth. Ellie, I'm going to ask you just to move to a chair to demonstrate the same objective can be achieved with an ordinary chair. And again, you can capture the medial malleolus, the MLA, right around the posterior aspect of the heel, and the lateral malleolus, all with your scan. There you go. Very simple, very straightforward way of capturing three-dimensional data for the provision of custom-made Richie braces made in 3D printed sustainable plant-based material.